So, one of the things. Okay, here we go.
Yesterday from the videos.
Is that when we have a trapezoid, trapezoid is quadrilateral, but it's a unique quadrilateral where it only has one pair, parallel sides. We're done. Any ideas how to solve? Now, when we look at trapezoids, the bases are the parallel sides.
4x minus 10 plus 3x plus. Wait, although half of 4x plus 10
So just because typically our trapezoids sit, yes, like that doesn't mean that the base is always at the bottom side. The bases. We said that the length of the median parallel sides. So in this case, TR is equal to half your base, some of the bases, correct? Your legs are the parallel sides. So TO, so TD. Okay. Remember, this is what we call the geometric equation. A lot of you guys skip this and say, okay, I'm going to set this up. The base angles, of the trapezoid, use the proper angle for the equation. Then it becomes really easy to know where to put things. What's the length of AC? We usually pair them together. So angle T and angle T are a pair of base angles equals half of, what's TO? Angle T plus angle R. Okay, so then I've got our base 13 is equal to half of 7x minus 2. Okay, now before we go further, what would you normally do at this point? So, if you want to say, okay, now let me ask you, our T and P, the problem is that now gives us a fraction with y, right? Can't really take 7 halves. Makes things a little bit more difficult. Yeah, so in this case, your base angles are multiplying by 1/2, correct?
Yes.
So in order to get rid of that,
Yes.
yeah. So, and how did you do that? What did you do? Multiply by 2/1. So you multiply both sides by that, it would still be, now we can't solve the 1/2. Now, I don't have to worry about fractions. Because your base is, again, is determined by the parallel sides, not by the orientation. Okay, so 28 equals 7x. So a lot of times when you guys have the half out in front, you don't necessarily are the two angles first. Okay, sometimes that works, sometimes it doesn't. But this is actually made our job easier. Okay, let's try another one. Same parallel line. So Connor, and basically what you're asking me then is, okay, where this trapezoid? Do that again? Where am I? Well, that's where you have to read the problem. Okay, all the problem would say was find x, so we're done there. If it said what is the length of ny, take 4 and plug it in. And so you'd have to read the directions, okay? So now your base. I'm going to skip this problem. And I want to go back to here. I want to keep practicing this a little more. Good job. So the base angle. Okay. Guys, find MN if WZ is 11 and XY is 3. So what is MN? Median. How do you find the length of the median?
Add the two bases together.
Well, that's more important. Divide by 2. So MN pretty much for any XY plus WZ all over, other than the fact that T. Alright, so MN add up what? Is what?
3 plus 11.
You take angle T and add to angle P, what do you get? So what you get is the same side interior angle. And that'll work with any trapezoid. And we get a very special relationship question for you. If XMN is, or find XMN if WZN is 78. And really, and this is kind of the big question I have for you guys on the video quiz. Well, not that many of you guys got this. If you notice right here at the very beginning, what type of trapezoid do we have? Isosceles triangle. Isosceles trapezoid. And I lop off the top.
XY is parallel to y.
What shape have I just created? Well, that's the fact that's what type of trapezoid. So just the diagonals through it. What else? So a lot of times this is a one that's a little bit more advanced. So therefore, W, especially for mathematics, you have the same measure. So W is Z, and truncated 78. Triangle. What does that make? A lot of times if you have like areas that are next to go. Now, because it's a trapezoid, because WZ body looks like it's going to be a pyramid. Also, what about if it's called a truncated pyramid? So to be truncated means literally have the top. It's half the sum of the bases.
Yes.
Is it parallel to my bases?
No.
Yes. Okay, that's something else you guys might want to remember, that the median is parallel to the bases. Now, with isosceles, so if this is 78, isosceles, what is that angle? Trapezoids, your base angles are equal. So those two corresponding angles. So that equals 78, and so are my top two angles by corresponding angles. Okay. And then we did discuss this. I want you guys to do yesterday. I mean, do we got that isosceles trapezoid? You guys get it? Yeah. All right, we're done. Okay. All right, we did talk about the median. You guys should have learned that from your Inspire activity. What did you guys learn about the median, the length of the median?
You gotta add up the two together.
So add up the bases, divide by 2. So ultimately, the big idea out of this with the median is that the median is half the sum of the bases. Median is half the sum of the bases. Okay. Let's get into some examples. By the way, how would you show that a trapezoid is isosceles? What would you have to prove? Nope. That's one way to do it, but it's a much easier way. The diagonals of a trapezoid are congruent if and only if it is isosceles.
So you have to make sure that both are facing.
Nope.
The diagonals.
You have to make sure the diagonals are congruent. So just like in a rectangle, we said the only way to show that something's a rectangle is to show that the diagonals are congruent. It works the same way with trapezoids. If you want to show that a trapezoid is isosceles, you must show that the diagonals are congruent. So let's do that. So verify that QSTV is isosceles. So let's start plotting these out. Q is negative 1, 2. S is at 1, 2. T is at 3, negative 2. And V is at negative 2, negative 2. Now, in order to prove that this is isosceles, what should be true?
Diagonals.
So we should make sure that our diagonals are congruent. But what are my diagonals?
VS and GG.
No. Oh, you said VS, Shay?
Yeah.
Okay, yep. So we need to make sure that VS is congruent to QT. All right, so let's find VS. Use distance formula. How far is it to go from negative 2 to positive 1? 3. So that's 3 squared. How far is it to go from negative 2 to positive 2?
4.
So 3 squared plus 4 squared is, actually comes out nice and perfect, so root 25, which is actually 5. That's a Pythagorean triple. Now let's do QT. How far is it from negative 1, positive 3? How far is it from 2 to negative 2? What's 4 squared? What's 16 plus 16? Are these the same? So VS is not congruent to QT, therefore, not isosceles. There we go. It's that simple. Yep.